Aircraft engines can be classified by several methods. They can be classed by operating cycles, cylinder arrangement, or the method of thrust production. All are heat engines that convert fuel into heat energy that is converted to mechanical energy to produce thrust. Most of the current aircraft engines are of the internal combustion type because the combustion process takes place inside the engine. Aircraft engines come in many different types, such as gas turbine-based, reciprocating piston, rotary, 2 or 4 cycle, spark ignition, diesel, and air or water cooled. Reciprocating and gas turbine engines also have subdivisions based on the type of cylinder arrangement, like piston, and speed range, like gas turbine. Many types of reciprocating engines have been designed. However, manufacturers have developed some designs that are used more commonly than others and are therefore recognized as conventional. Reciprocating engines may be classified according to the cylinder arrangement, like inline, V-type, radial, and opposed, or according to the method of cooling, such as liquid-cooled or air-cooled. Actually, all piston engines are cooled by transferring excess heat to the surrounding air. In air-cooled engines, this heat transfer is direct from the cylinders to the air. Therefore, it is necessary to provide thin metal fins on the cylinders of an air-cooled engine in order to have increased surface for sufficient heat transfer. Most reciprocating aircraft engines are air-cooled, although a few high-powered engines use an efficient liquid cooling system. In liquid-cooled engines, the heat is transferred from the cylinders to the coolant, which is then sent through tubing and cooled within a radiator placed in the airstream. The coolant radiator must be large enough to cool the liquid efficiently. The main problem with liquid cooling is the added weight of coolant heat exchanger and tubing to connect the components. Liquid-cooled engines do allow high power to be obtained from the engine safely. An inline engine generally has an even number of cylinders, although, some 3-cylinder engines have been constructed. This engine may be either liquid-cooled or air-cooled and has only one crankshaft, which is located either above or below the cylinders. If the engine is designed to operate with the cylinders below the crankshaft, it is called an inverted engine. The inline engine has a small frontal area and is better adapted to streamlining. When mounted with the cylinders in an inverted position, it offers the added advantages of a shorter landing gear and greater pilot visibility. But, with an increase in engine size, the air-cooled, inline type offers additional problems to provide proper cooling. Therefore, this type of engine is really confined to low and medium horsepower engines used in very old light aircraft. Opposed or O-type engines. The opposed type engine has 2 banks of cylinders directly opposite each other with a crankshaft in the center. The pistons of both cylinder banks are connected to the single crankshaft. Although the engine can be either liquid-cooled or air-cooled, the air-cooled version is used predominantly in aviation. It is generally mounted with the cylinders in a horizontal position. The opposed type engine has a low weight-to-horsepower ratio, and its narrow silhouette makes it ideal for horizontal installation on the aircraft wings, especially in twin-engine applications. Another advantage is its low vibration characteristics. In V-type engines, the cylinders are arranged in 2 inline banks generally set 60 degrees apart. Most of the engines have 12 cylinders, which are either liquid-cooled or air-cooled. The engines are designated by a V followed by a dash and the piston displacement in cubic inches. For example, V-1710. So, this type of engine was used mostly during the Second World War, and, its use is mostly limited to older aircraft. Radial engines are pretty interesting. Basically, the radial engine consists of a row or rows of cylinders arranged radially about a central crankcase. This type of engine has proven to be very rugged and dependable. The number of cylinders which make up a row may be 3, 5, 7, or 9. Some radial engines actually have 2 rows of 7 or 9 cylinders arranged radially about the crankcase, one in front of the other. These are called double-row radials. One type of radial engine has 4 rows of cylinders, with 7 cylinders in each row for a total of 28 cylinders. Radial engines are still used in some older cargo planes, warbirds, and crop spray planes. Although many of these engines still exist, their use is limited. The single-row 9-cylinder radial engine is of relatively simple construction, having a one-piece nose and a 2-section main crankcase. The larger twin-row engines are of slightly more complex construction than the single-row engines. For example, the crankcase of the Wright R3350 engine is composed of the crankcase front section, 4 crankcase main sections, front main front center rear center, and rear main rear cam and tappet housing supercharger front housing supercharger rear housing and supercharger rear housing cover. Pratt & Whitney engines of comparable size incorporate the same basic sections, although the construction and the nomenclature differ considerably.